Question 1.3. Consider the product 1 times 2 times 3 times 4 times till you get to 30. And the question says determine the largest value of k such that 3 to the power k is a factor of this product. I mean, this is just for 4 marks, so this is your level 4 question at the end of your algebra section, and a little bit unorthodox in this 2019 paper. So first things first, what we need to understand or actually take note of is this first part that they gave. Alright, so we're going to break this question up, or this information that they gave us, and ideally this part here, this is called actually a factorial. So if you multiply 1 times 2 times 3 times 4, all the consecutive numbers until you get 30, that is the same thing as writing, let's just rewrite this, 1 times 2 times 3 times 4 all the way 5 6 7 all the way to 30. That is the same thing as writing 30 factorial. So slightly unfair since this is algebra and this is more of a probability type question where you'll actually learn that this actual exclamation point here is called a factorial, which you learn in probability. But nevertheless, this is assumed that the whole year syllabus is completed and you understand what a factorial is. So right, so nevertheless, since we understand okay what it's called, 30 factorial, so this is what we're considering. And now it's saying determine the largest value of k such that 3 to the power k is a factor of this product. So in simple terms, what they basically trying to say here is that this product, whatever 30 factorial is, you can put this in the calculator, and whatever value you get here, our factor, or 3 to the power whatever, has to be a factor of this product. And if we come back to the simple understanding of what a factor is, if I ask you, okay, what is the factor of say 12? Factors of 12, let's say 1 and 12, 2 and 6, 3 and 4, and that's basically our factors. So ideally 3 to the power whatever, and this is the largest value of k, so we need the largest value such that 3 to the power whatever that number is multiplied by something should give us 30 factorial. So in simple terms, what this entire bottom part basically means, and because of the fact that they're using 3 to the power k as what they want, they basically want you to only look at the multiples of 3. So in this product, we are only going to look at the multiples of 3. So from this product that they've given us, this 30 factorial, and I'm going to reformat it, we are only going to look at 3, 6, 9, 12, 15, 21, 24, 27, and then of course 30. So ideally we're going to exclude out all the values that does not have a multiple of 3, because if we look at it, they said 3 to the power k. If they said 4 to the power k, you're going to look at all the multiples of 4. So this is what they trying to expect you, or what they want you to do here. So we're trying to figure out that value of k, 3 to the power whatever, and 3 to the power k just basically means 3 times 3 times 3, well, k times, right? Whatever k is, that we're going to figure out now. So now that we refocused our understanding of this product into only the multiples of 3, now we need to break these up into factors of 3, because as you can see, so some of them we only want factors of 3. So if we look at this, we need to count how many 3's there are essentially that we're going to multiply from this bracket of numbers that we have chosen of the multiples of 3. So coming back to this, we're going to do this here. So this is basically 3 is 3 to the power 1, because 3 times 1 is only 3 there. 6 would be 3 times 2, right? So ideally I'm only worried in the 3's, so here this would be 3 squared. 12 is 3 times 2 squared. So I'm basically looking at it in its prime or factored form of that specific number. So I'm breaking each multiple of 3 in 30 factorial, and I'm reducing it into its prime base or simplest factored form. 15, that would just be 3 times 5. 18, that would be 3 squared times 2. So there's tricks in the calculator to actually get something like this here, but ideally our focus would be 3. 21 would be 3 times 7. So 3 times whatever must give you that answer. Alright, so 24, that would be 3 times 2 cubed, or 3 times 8, 3 cubed, and this would be 3 times 5 times 2, essentially, yeah. So again, our only concern is our threes, so we need to count how many threes there are, and we need the largest value. So here this, I'm just going to highlight our threes so we know when we're counting how many we have. And here, well, there's one here, there's one here, there's two here, there's one here, one again, 2, 1, 1, 3, and 1. And after we tally all of this together, we should get 2, 4, 6, 8, 10, 14. So therefore, counting all the threes from the different multiples of 3, we get k is equals to 14. And what this means is 3 to the power k, in this instance we figured out what k is. 3 to the power 14 is the largest value, 14 is the largest value of k, such that 3 to the power 14 is a product of, or factor, sorry, of the product of the t factorial.